Hello guys, welcome to another class in chemistry. Now this time we're gonna talk about molar volume of a gas. This time we're gonna talk about how to get the amount of volume from a sample in moles of a gas, or the opposite. You have the volume and you want to know how many moles are those. Now, to know it, or to start working on that, we need to know that at standard temperature pressure, all gases have a volume of 22.4 liters. But what is STP? As you already read in the file that I sent, STP stands for standard temperature and pressure. In other words, that means we're going to consider a temperature to be 0 Celsius degrees and a pressure to be just 1 atmosphere. Now let's take a look at the sample problem. In part A, it says, what volume does 0.0685 mole of gas occupy at standard temperature and pressure? So, first, we always start with the given, as I already explained you many times in my classes. So, I have to highlight the givens. I have number of moles and I need volume. I have a volume and I need quantity of gas in moles. Okay. As we are referring to STP, we already know that we can apply this process. So we say, in part A, they are giving us 0.0685 moles of gas. Now, I can use my equations here, my conversion factors, okay? Remember that sometimes we can use this as a conversion factor. Now, as I have moles here in the top, I will use the second because moles is in the bottom. So I know that in 1 mole, I have 22.4 liters of the same gas. Okay, now I can cancel. And in my final answer, I will just multiply 0.0685 times 22.4. That gave me 1.5344 liters of gas. What happens in B? Now it says, what quantity of gas in moles are contained in 2.21 liters? So they are giving me the volume, 2.21 liter of a gas. We still don't know what gas it is, but we can just write that it's about a gas. Now, here I have liters. Liters are given, and it's in the top. Now, the relationship that I will choose is the one that has liters below, so I can cancel. I will choose number 1 expression, so I say in 1 mole of the same gas I have 22.4 liters. Now I can cancel my liters and I will divide 2.21 times 1 divided by 22.4. This gave me an amount of 0.099 moles of the same gas. So as you can see, guys, this topic is very easy. It's basically conversions, but the only condition that you need to actually be sure that you are having in the problem is that your gases are specified to be at the standard temperature and pressure. Okay, now let's take a look at the next problem. This is about the topic gas volume stoichiometry. So as you can actually think, it is about stoichiometry, but now, this time, we're going to talk, or we're going to use, instead of grams, we're going to use volume. Now, what happens in this problem? Propane is a gas that is sometimes used as a fuel for cooking and heating. The complete combustion of propane occurs according to the following balance equation. It's already balanced, we don't need to do any balancing at all. Now, in the first part it says, what will be the volume in liters of oxygen required for the complete combustion of 0.35 liters of propane? And part B, what will the volume be of carbon dioxide produced in the reaction? Assume that all volume measurements are made at the same temperature and pressure. Now, let's take a look. First of all, we are talking about a gas, of course. And in part A, they are asking us to find the volume in liters of oxygen. So, in A, my unknown is oxygen volume, unknown. But they are giving me propane. They are giving me its volume to be 0.35 liters. Now, from this we can start. As I already mentioned too many times probably, we always start with the given. So we're going to make use of the old stoichiometry that we learned. Now we're going to apply it right here with the new conversion factors that we just learned. Now we always start with the given, and we can say 0.35 liters of propane. Now, I want to know my liters of oxygen. So I will relate propane and oxygen. So the relationship, the molar relationship that we have over there is in 1 mole C3H8 we have 3 mole 5 mole of O2. Now we can convert this also. Okay, now we can use the same relationship that we used to do with moles, but now, as I told you in the presentation, instead of moles, here in this type of problem we're gonna use liters, because this is volume relationship, okay? Volume relationship. So instead of moles, we're gonna say 1 liter of propane against, instead of 5 mole, we're gonna say 5 liters of oxygen. Now, propane is given, so it is in the top. So I will write my propane below, so I can cancel the liter of propane. In the top, I will write the other relationship, that is 5 liters of oxygen. Right now, I cancel here and there, and I will multiply 0.35 times 5. This gave me 1.75 liters of oxygen. Now, in part B, what will the volume be of carbon dioxide? Now I'm talking about carbon dioxide. And of carbon dioxide, what will the volume of carbon dioxide produce in the reaction? Assume that all volume measurements are made at the same temperature and pressure. So, they are giving me the same. My propane is the volume given, that is 0.35 liters, and I need to know CO2, its volume. That is my unknown. So now I will place this here. Now the volume relationship will be between carbon dioxide and the given, that is propane. So I will have 1 liter of propane against or versus 3 liters of carbon dioxide. As in every chemistry problem, we always start with the given. We say 0.35 liters of propane times the relationship. Now in this case, my liters of propane is in the top, so I will choose my liters of propane to be below. 1 liter C3H8, 3 liters of CO2. Now I can cancel my liters of propane in the top and also below. And my answer is 0.35 times 3. 1.05 liters of CO2. And voila.